Welcome, ladies and gentlemen, here to the forum of the group exhibit Hydrogen, Fuel Cells and Batteries. I'm looking now for a very interesting panel discussion here on stage. We have the Fuel Cell and Hydrogen Joint Undertaking with us, and we want to show how they can support European small and medium-sized enterprises, accelerating technological breakthroughs. So I would like to welcome Bart Biebuyck right next to me. He's the Executive Director of the Fuel Cells and Hydrogen Joint Undertaking. I would like to welcome Enn Õunpuu. I've learned that means apple tree. Also, okay, Mr. Õunpuu, you're the founder and member of the board and CEO of Elcogen. Good to have you here. I would like to welcome Dr. Martin Schneider, Head of Product Management of Hydrogenious Technologies GmbH, and last but not least, opposite to me, Pieter Veltman. He's Commercial Director of HyET BV. So HyET stands for High Yield Energy Technology. So good to have you here, Pieter Veltman. So, and whenever you have a question, just raise your hand, be right with us. I'll come with a microphone right to you, and you can give the question to the gentleman here on stage. Bart, we would like to start with a Fuel Cell and Hydrogen Joint Undertaking. This is a public-private partnership the European Union has initiated to support research, technological development and demonstration activities in fuel cell and hydrogen energy technologies. Who are the partners of this public-private partnership?
Yes, thank you very much, and thanks for having us here and giving us the chance to explain a little bit what the FCH JU is and what we are doing with SMEs. But so to answer your question, now we have three partners in principle. We have, of course, the European Commission on one hand, and then we're working very close together with the industry. We have, and they call themselves Hydrogen Europe. They're about 130 companies, and I think most of the companies here today that we can see here in the exhibition are member, of course, of Hydrogen Europe. But important is that 50% of them are SMEs. Maybe we could talk about that a bit later. On the other hand, the partner is also the research institute. So around 68 research institutes, well balanced all over Europe, are also a member of that group, and they call themselves Hydrogen Europe Research. So together, Commission, researchers, industry, we put money on the table really to fund projects in Europe.
But these are completely different worlds. The world of politics, the world of academia, and world of business. So do they communicate with each other, or how does it work?
Yeah, and that's exactly what the FCH JU is so important for. Because what we do is we build an ecosystem. We're bringing all the partners together, and we are discussing what should we do. How do we move forward with the fuel cells and hydrogen? What kind of technology we should do? We prioritize all together. And so, yeah, it's not always so easy, as you said. Of course, you have a certain academical approach, you have a certain industry approach, but I think it's crucial that we spend the money wise. And by discussing together, that's what's happening. And as well, it's important for the industry to tell what exactly they need for their products to bring it on the market, and that the research can really be exactly helping the big industries or the SMEs supporting to make that product. And so that's very unique. Okay,
so you really could say the FCH JU is an instrument of governance for innovation, and the public-private partnership model is enabler for implementation of the hydrogen and fuel cell technology.
Yes, exactly.
Okay.
So, yeah, exactly. And I think here today we have three of our beneficiaries and SMEs. And maybe it's important to mention that in our Horizon 2020 and our FCH JU, about 25% of all the money goes actually to SMEs.
Yeah, it's the second joint undertaking, we have to tell that. And one of the goals of the second undertaking was to increase the participation of SMEs. Did you succeed in that goal?
Actually, we over-succeeded what we had to do, because the aim of Horizon 2020 was to have only 20% of the money going to SMEs, but actually today I can tell you we have 25% of the money going to SMEs. And if you know, 110 million euro goes to SMEs, that's a lot. And these gentlemen here together get about 7 million euro. But so there are a lot of SMEs, as I told you before.
let's prove that SMEs are important to bring this technology up. So we have 3 examples of that here on stage. I would like to ask you, Mr. Õunpuu, the support of the Fuel Cell and Hydrogen Joint Undertaking on a funded research project enabled a small company from Estonia, that what you are, to become, well, one of the most efficient solid oxide fuel cell manufacturer with a most efficient ratio of 74%. Or what can you reach already?
Yeah, actually, these projects, we are now participating in 4 different projects, and the projects are different, starting from say technology improvement. Improvement efficiency, as you mentioned, 47% of electrical efficiency, which we have achieved during one of our projects in our stack. Then we have a project where we already now started high quality mass manufacturing process development and quality control for that. And then we have 2 projects where we have direct connections to our customers. So our company, we make solid oxide unit cells and stacks, and our customers are different companies who then integrate the stacks into the systems, like power production in small scale, commercial, industrial power production, and also electrolysis for hydrogen production. So we have also 2 projects in these areas.
Mr. Õunpuu, you have to explain that to me. You're a small Estonian company, but you reach to get the highest efficiency at the lowest temperature as well. 650 degrees you only need with your SOFC. Well, was that only by the funding of the joint undertaking, or also came by your own brains?
No, yeah, we started 17 years ago, and then practically from scratch. And from the beginning, our idea was to bring down the operating temperature below 700 degrees C, which we think gives our customers a lot of benefits in cost reduction, in stack and system level. And cost reduction, as we know, is a main, driving force to get the technology to the market as soon as possible. Yeah. So, and also one of our projects where one of our customers, this Finnish company Convion, is developing the 2nd generation CHP system, 60 kilowatt system, around our lower operating temperature. And the most important with these projects is networking. So in fuel cell business, it is clearly, we can see that no company can manage by themselves alone. You have to cooperate not only with academia, which is extremely important in research, but also with other stakeholders, the businesses in fuel cell business. So and this is this joint undertaking, and the projects are the one platform where you really can cooperate with the academia and other companies.
Dr. Schneider, let's talk about your company, Hydrogenious Technologies. There's a genius already in the name, of course. So you found a breakthrough in hydrogen storage. You developed a safe, efficient storage of hydrogen in liquid organic hydrogen carriers. Please tell me a little bit more about that, LOHC.
Sure, absolutely. Pleasure to be here. Thank you very much. So our technology development started around about 9 years ago with the cooperation between BMW and the University of Erlangen-Nuremberg in Germany, Bavaria, to develop a new technology for hydrogen storage in simple liquids, which are oils that can be transported in conventional fuel infrastructure, just like gasoline or diesel today. So no high pressure or cryogenic hydrogen equipment necessary for the whole hydrogen supply chain. And in these liquids, you can transport hydrogen at a particularly high storage density in a very simple and easy way. The liquids are hardly flammable, non-explosive, not considered a dangerous good for road transport. And we took this technology and now commercialize it for hydrogen logistics applications. So for the question how to store large quantities of hydrogen or how to transport large quantities of hydrogen to deliver it to a refueling station or similar. And we started as a small company 5 years ago with only 5 people and scaled it up in 5 years' time to 55 people now, and are active in Germany, in Europe, with the support of the FCH joint undertaking now in the high stock project, and now also ship the first systems to the US and will ship the next 2 systems to China next year.
Dr. Schneider, I've learned in 1 cubic meter of LOHC you can transport 600 cubic meter of hydrogen, and without compressing it and without liquefying it, but you still lose some energy, don't you?
Well, of course, if you want to store hydrogen, no matter which technology you use, you have to take some energy to either compress it or to liquefy it or to store it in our liquid organic hydrogen carriers. The good thing with our technology is that it is very scalable in terms of how much hydrogen you want to transport or store. So you could easily imagine a conventional tank truck transporting and storing more than 1,600 kilograms of hydrogen, which is 6 times more than its conventional tube trailer for hydrogen. Or you could use train transport or ship transport using massive scales, which is very easy by means of these LOHC liquids using just conventional fuel structure, infrastructure solutions that we already have today for fossil fuel transport.
So I could imagine the hydrogen is produced at a certain centralized place. A lot of hydrogen can be produced there, and you bring it within the liquid to different stations, like a hydrogen refueling station, for instance. What happens there? You release the hydrogen there, or what is your plan?
Yes, exactly. So we have centralized storage units and decentralized release units. So you would have either containerized solutions up to more than 20 kilograms of hydrogen per hour can be realized in standard ISO containers, or for bigger solutions we also have rack-based solutions available. And you would release the hydrogen out of these liquids and put it into the high-pressure cascade storage or whatever.
You have to compress it again, don't you?
Of course, you have to compress it to the pressure that you need to refuel the cars, but you would have to do that for high-pressure supply chain as well. So you have a very similar supply chain.
Inside the car, Dr. Schneider? Why don't you release it inside the car?
This is a very, very interesting outline. Thank you very much for that. This was the initial focus of the development of BMW, to bring this technology on board of cars and use our fossil fuel infrastructure that we already have today. Use the same fueling stations, the same technology. This is already, or is still on the horizon, but it's not our commercial focus at the moment. Okay. Of course, you could think about that, but maybe not on a BMW 7 Series, but maybe on a ship or a train first, and then optimize the technology and make it more compact and really realize it as an onboard application as well.
Exactly, yeah. On ships and large engines, they need very compressed fuels, so that might be also an application. Quite interesting what you told me, Dr. Schneider, and also interesting, Mr. Veltman, what you are doing at HyET Hydrogen. You have developed a breakthrough electrochemical hydrogen compression and purification technology. Please tell me more about that.
Okay, electrochemical purification and compression is, in essence, it's been described before, a fuel cell in reverse. So you apply a voltage over a membrane, and through the membrane only hydrogen can pass through. And if you keep transporting, and transporting means keep pushing a current through the membrane, you compress the hydrogen. And we have achieved, but that was back in 2011 already, a world record of 1,000 bar. So that means that in a single step you go from almost ambient to the pressures needed for the hydrogen refueling for automobiles, which is currently set at 875 bar for the station. And because it is a membrane, only the hydrogen passes through, so you automatically have the purity level that is required for fuel cells. And this technology is quiet, it's compact, there are no moving parts, so it has a better availability and reliability than, let's say, mechanical compressors. And it's a single stage technology, so it's much simpler.
So Veltman, you could say it's electrolyzers without water, isn't it? So you you just push the hydrogen together, you know, and compress it by that way. But you still need electricity for that, isn't
We
it?
need electricity, yes, definitely. And any compression technology will require energy. And mostly they are electrically different also. So it's all about the number of kilowatt hours per kilogram that you need to compress the hydrogen to 875 bar.
So do you need less electricity to compress it than conventional compressors?
We are now at about par, and some of the projects that we're doing with the support of the FCH JU is to increase the efficiency. And we have clear visibility on getting to a point which is much lower than the energy consumption for mechanical compression. And the key there is that at these very high pressures, it doesn't really matter so much to what pressure level you go with an electrochemical compressor. So whether you go to 500 bar or 900 bar requires only a little bit of extra electricity, and we don't need a new stage. It makes it all much simpler. So we are especially competitive at these very high pressures.
And the good thing about this electrochemical compression is it's so pure.
Yeah.
So even purification of the already pure hydrogen, it's even purer. In normal compression, in traditional compressors, you always have a little amount of oil in it or carbon or whatsoever. So there's no impurity in the other.
Yeah. In normal compression, you have a risk of oil, and in our case, not. And we could even take, let's say, a mix of gas where there's nitrogen and methane in the gas, and only take out the hydrogen. So we don't have to work with pure hydrogen to start with. And that could be very important if, let's say, gas networks are used for gas mixes, where hydrogen and natural gas are mixed in the same pipes.
But it's not possible to take CNG and compress it to hydrogen. Or
No. So,
Okay.
we still need hydrogen atoms to start with.
Okay, that would be a nice invention indeed.
Yeah.
But these are three wonderful examples of highly innovative SMEs in the field of hydrogen fuel cell technologies. How could the joint undertaking support them? Mr. Õunpuu told us already about different funding projects. What else do you do with these companies?
Well, I mean, of course, funding is one thing, but on the other hand, also we bring them in contact with many companies, also with bigger companies, which are then probably willing to invest in those companies, buying shares or whatever, and who are willing to do some projects together. And maybe in future there's a commercial contract possible. We don't know, but we have already some examples where we see that this is very beneficial for an SMEs to work together. On the other hand, so they're getting the contract, I mean the network, and they're getting the chances maybe to later on to build business cases with them.
Mr. Õunpuu, but you could really say maybe it could be the case that Elcogen wouldn't be known in the community if there wasn't FCH JU. Not so well known.
That I don't know, but for sure participating in these projects have helped us. And the most important, I think, is that we have found partners, and we are actually creating the supply chain from raw materials, components to systems, and this European value chain. That's important what we actually can do with these projects.
Bart, and it's quite interesting that you can fund a lot of different projects, like research projects, of course, but as well as manufacturing processes. You could also fund. Does it go up to market introduction projects?
Yeah, exactly. So, of course, research, we heard here already a lot of research projects, but we also do manufacturing. So, for example, the small SMEs, once they have a fantastic device, they have to be able to manufacturing it. So we also help to build up, for example, the manufacturing facility, how to do it fast and quickly. So we have some of projects also like that in for SMEs as well. Yeah.
Dr. Schneider, what meant the support of the joint undertaking to your company?
So first of all, what Bart already said, that there is a platform of companies in Europe that take hydrogen seriously and take you as a small company seriously when you enter this community. We are a member of Hydrogen Europe and therefore are also a part of the community now that is integrated within the FCH joint undertaking.
You have to say Hydrogen Europe is the industry part of the joint undertaking. Yeah.
And we are a member of that, and therefore we are a member of the FCH joint undertaking group. And it helped us to get in touch with companies to build a consortium for our high stock project, which started just this year, where we receive funding from the FCH joint undertaking for building up a demo project in Finland with Voikoski as a hydrogen logistics partner. So it helps to take out the risk for companies that want to apply new technologies from SMEs like us in Europe and showcase these projects, and then we can take it from there. So it helps to establish first cooperations and to introduce small companies to larger players in the field.
Yes,
and maybe please. To add to that,
Yep.
automatically you build trust. Because there are two companies, they don't know each other, and then they have a joint project in a consortia, and you build trust. And I think this is also important, to have this chance.
But did it already happen to one of you that after a project you went on with another project not funded by the joint undertaking? Did it? Mr. Veltman, tell me.
Yeah, we work with some companies on projects, and with some we continue, let's say, implementation scale. Don't forget that some of these projects, let's say, we are complementary. What Hydrogenious does, we take and compress it. So there are a lot of synergies between the companies, and from that perspective, I look at the joint undertaking and Hydrogen Europe as a relatively small dating site, but very specific. So most of the partners are interesting, and it's very specific. And because you're all, let's say, confined to each other, you have automatically like a rating system. You know, people are really committed because you build up a reputation within the group, and that's important because you want to follow up, you want to do the next project. So it's a great way to get to know each other, and especially when you're growing, the commercial risks of the projects become bigger, and then it's good to know each other.
And that's the best way to give funding when in the end it becomes super fluent. So they don't need any funding anymore. That's the best goal that you can have, isn't it?
That's of course our aim. I mean, Europe is putting actually money in this technology really to accelerate the development. But at the end, it has to live by themselves. So it has to become commercial viable. And yes, this is the best way to do it, through such a public-private platform.
Maybe one thing I have to highlight is that the joint undertaking is focused on fuel cells and hydrogen, which means that then you have a project application. You know that you are competing, apples with apples, not H2020 general call. Then you have to compete, fuel cell company against IT, or it's very general and much harder to get financing, because in this case it's very specific calls, and you go into this call and it's focused. That's important.
I would like to open up this round and look around. If anybody has a question, please raise your hand. I'll be with the microphone right with you. What is, for you, Mr. Veltman, is the role of the high-ranking research institute, European Research Institute? You can work together. Is that this contact also came from the joint undertaking, doesn't it?
Yes. So some of our projects. We are very application driven, but sometimes you need a theoretical foundation. For instance, really understanding what happens on a molecular level inside a membrane. And for that, let's say, research institutes are very important. They have the tools, they have the know-how, the specialism, that for a small company like ours are simply unavailable. So that combination is really very powerful.
But I ask myself, does also the industry, the large industry, can profit from the agility of the SMEs?
Absolutely, because sometimes you see that big industries are not yet willing to take the risks. So, and they like to work together with huge innovators, like we have here, 3 companies, a very innovative company. And basically, yeah, they take the risks a little bit. And then if they see if something comes out, they jump on it.
They jump on it and they take shares, don't they?
Yeah.
Yeah.
Your company
We don't mind.
Shell Technology Ventures and Anglo-American Platinum, right?
Yeah.
Okay,
Yeah.
they took shares.
Yeah.
Not the worst result for an SME, are?
No, it's fantastic. And Anglo is also an investor in Hydrogenious. So
Right.
let's say from that
They
perspective,
understood that you both stick together. You're very
Yeah,
close, in your technologies, indeed, yes.
yeah, it helps. I think it helps both companies. And Shell, of course, is an important potential customer. And I think that they clearly see the importance of the technologies that are being developed, and that we need those technologies. And basically, what Mr. Biebuyck said, they sit on the fence and they watch what's going on in the kindergarten, and then the ones that are really good, they pick them out. Yeah, that's life, but it works as long as the good ones get the opportunity to develop. And I think that the joint undertaking is instrumental to that.
But maybe sometimes it's better not to pick it up. I know Google was close to be bought by IBM, but they were too expensive. So
Yeah, but I think there's a huge difference between, let's say, developing as an industrial company and really building products, and being a Google. Because if you look at, let's say, the investment levels that were needed for Google in the first years, and you compare it to, let's say, the investment levels and the risks that are come with our type of industry, they are incomparable. And that's also why you see a totally different investment climate. It's incomparable.
go ahead.
Maybe to add to that, if we really looked at the FCH 1, so the first generation from 2008 to 2014, there we didn't have so many big industries, because there it was really research and very low-scale demonstrations. What we see in the second generation of the FCH, that suddenly the big industries became partnering. And of course, this was, that was very good news for the SMEs, because they suddenly got the connection. So you really saw, when we started really basic research, then you now move to the market, and then they jump in, also the big industries.
Dr. Schneider, I can imagine to have a funded project on European level. You know, you need at least 2 or 3 people in your company who work just to get the project paper done. Isn't that true?
Well, actually, it was pretty much a one-man show or a two-man show in our company. So in small companies like ours, you have to take responsibility for many different subjects, and there is only very limited personnel available. And in our case, our head of business development at that time and COO at the moment, Dr. Cornelius van der Heid, and myself wrote the application for these projects ourselves.
And this worked. You didn't need an study for that.
No, we were told it was the best application ever to be put in with a score of 14. So it was a pretty successful one.
So if you have the opportunity to either have a national funded program or European funded program, which one would you choose then?
Well, we would absolutely choose a European funded project, because as a very small, starting as a very small company 4 years ago, trying to apply for national funding, we had difficulties, to say the least, with the bureaucratic kind of apparatus around it. And we have seen that given the operational excellence that you need to receive European funding, you have to be excellent. But if you are excellent, then the bureaucratic hurdles are much lower compared to national funded projects.
What are the special problems that startups like you're funded in 2013, as far as I know, that you're facing with national funded project?
Well, first of all, as small companies, you have to reach a certain level of popularity. So at first you're not known compared to big corporations, and this makes it harder for you to receive funding because your technology or your company is not known in the first place. That was 4 years ago. And as well, you have to show that you have enough liquidity for a national funded project to come up with the 40% fund that you have to bring as a company to the table.
How can you do that if you're at every 2 or 3 years an investor round?
Exactly. If you have investor rounds every 2 to 3 years, you cannot show this liquidity to the funding partner. So therefore, it is very hard to receive national funding because you only have a startup bonus, so to say, at least in Germany, if you are in existence for only the first 2 years. So, and I want to see that startup that starts a company and only within 2 years go through all the bureaucratic apparatus to apply for funding and be successful with that. That was a very harsh hurdle, and we have been successful, first of all, at the FCH Joint Undertaking funding with the HyStock project started this year, and in the SME Phase 2 project, which is also a European funding particularly for small and medium enterprises, where the competition is very hard, but if you succeed, the bureaucratic hurdles are very low.
Yeah, for me, it's the first time that I hear that European funding is much easier to obtain than national level funding. Could you agree to that, Mr. Veltman?
Well, I wouldn't say easy necessarily, but I think more realistic. And I think that the European funding, and I happen to know a little bit about the German system, the European funding is also realistic in the sense of what can you expect from a company up front, but also during the project. These are development projects, so they are not the outcome. There's no guarantee on a good outcome, and what often happens is during the course of a project, you simply notice this is not going to work like this. We need to change course. In some programs or in many funding programs,
startups call this pivoting, huh?
Well, yeah, but you got to be. You want to move on, and this is still forward compared to, let's say, here. But at least you're not going there, or you're not standing still. And you need to, within the European framework, you can explain this is not working. We need to change direction. Maybe switch a partner in the project, and that is all possible because at the end of the day, let's say the program managers understand that this can happen, and if you have a good alternative, a good plan B, that is acceptable. But I would say it's not easier. You still need to really be able to argue, make a strong argument for what you need and what you want to do, and how you want to do it.
Of course, you need strong arguments, but if they are good arguments, you are more flexible, maybe.
Yeah.
You can react to these arguments and say, well, if the goal has changed, okay, go with it.
Yeah, of course, you have to stay within a bit of the scope of your project. But for us, I mean, we are here to help businesses. We help the researchers. They need to achieve what they are aiming for. And maybe the original route was not the best way, but maybe another route, and we try to help them in that. So we basically try to help them not to make their life difficult. So, I mean, we are together the same aim to develop this technology, and we work together very closely and are very flexible in a way to help them as much as possible to reach their goal as fast as possible as well, because time is, of course, for SMEs very important.
Okay, so it's very important to support the SMEs, and you're very proud of fulfilling 25% of your funding goes to SMEs. But I ask myself, why not 50% or even more?
Yeah, would be possible, but I think we need to be realistic as well. I mean, there are a few things. Of course, you have the capacity of SMEs. Most of the time, I mean, we have SMEs with 5, 10 people. I mean, you started also with... So they don't have the capacity to work with 100 people on one big project. So most of the time they join in that are smaller scale projects. And then additionally, okay, it's a public-private partnership, so also from the private side you have to put in the money. So once you go to demonstration projects, you have to put in money. So big demonstration projects of millions of euros, and you have to pay maybe 30 or 40, 50% of it, is not so easy for SMEs, you know?
Of course not, yes.
And so
right.
I think these are a bit the limitations of it, but yeah.
But if you have the opportunity to support SMEs,
They're
you
more than welcome to
more
do
than
so.
welcome indeed. So if there are any SMEs here in the room, so just contact Bart or his collaborators to have interesting projects running, funded by the joint undertaking, of course. Last personal question to you, Bart. What do you think? Will the big players in the hydrogen economy make the big money in the end, or do you think there will be new technology trends that will produce new players, well, like Google, Facebook, or Twitter we've seen in the digitalization's world?
I think there will be both types will be there, but I'm sure that the SMEs, the innovators, will be the winners. That I'm sure, because whether finally your company will be sold maybe to a big company, okay, you as an SME, in a way, you're a winner, financially at least in that case, and your technology will be used. On the other hand, if you really make it and there's a new market now coming and you decide to go by yourself and to go alone, yeah, you also have a bright future, because the opportunities are just bright, really. It's amazing what will come in the next 10 years. There will be huge opportunities for SMEs. But I think the important will be to scale up. So they will need to be able to find the money to do the scaling up quickly. And that's sometimes why they need also these big companies, because you have to invest in manufacturing lines, you need to have investing in staff and so on. And that's very expensive. And for an SME, it's not always so easy to directly do that.
So, gentlemen, I wish you very much that you can scale up and that you are going to be the big players in the field of hydrogen and fuel cells in the future. I hope that you will be very successful. I would like to thank you all for being here, for having this discussion, and I would like to thank you, the audience, for joining us. Thank you very much.
Maybe just...
Yeah, I will announce it. Yes,
oh,
of
okay,
course.
great.
Yeah. So the last thing I would like to say is, of course, we have a reception here for the fuel cell and hydrogen joint undertaking, which will take place in our lounge over there, and everybody is highly invited to join us there for our reception, which will start right now in 1 minute. Just go over there. We all take you with us to have a reception there. Thank you once again, gentlemen. Thank you, ladies and gentlemen, here in the audience, for joining us. Thank you.
Thank you.